Hello, and welcome to the third installation of Math with Sensei Brian. I'm Sensei Brian, your math coach. I hope you had a pleasant time, a pleasant week. I try to do 1 to 2 of these a week. But please, if you like what we're trying to do here, hit the thumbs up or the like button and subscribe. It would really help me out. It lets me know that I'm reaching people, and it's encouraging to know that I'm helping people. Let's get started. Today's video is going to be on properties of math. Well, what are properties? Are characteristics of any given set of functions. Characteristics, you can say how a number acts or how a function acts, if you will. And there's 5 primary that we're going to go over today. The associative, the commutative, the distributive, the inverse, and the identity. Okay? Let's start with the first one. It's associative. The associative property. Now, do you remember what an enclosure is? An enclosure, parentheses, braces, brackets. Those usually have numbers or variables inside of them. Okay? How did that come into play with the associative property? Well, let's start with addition, because since addition is the basis of math, let's start with addition. Let's say A, B, and C, right? So A plus B plus C. By itself, we don't know what that equals, right? Because right now, these are just variables. They can mean anything. But let's give them a value. Right? Okay. So I'm going to erase A plus B plus C, and I'm going to plug numbers in there. Okay? We'll do this 3 plus 4 plus 5. Now, how does the associative property come in? Let's enclose these two numbers right here. So, now, in mathematics, anything that's in an enclosure, when you have mixed numbers in here, right? Well, not really mixed numbers. When you have multiple numbers inside of a set, 3 plus 4, you do this first. Okay? 3 plus 4 is 7, plus 5 equals 12. Okay? We'll get into this. It's called the order of operations. You always do what's in enclosures first. Okay? But still, as you can see, 3 plus 4 plus 5 is 7 plus 5 equals 12. Okay, let's mix this around a little bit. Now, again, we do what's in the enclosures first. Bring this 3 down. 4 plus 5 equals 9. And my friends, 9 plus 3 equals 12. Seems to be the same thing, doesn't it? Okay, not bad at all. So, we know the associative property of addition, if you move the enclosures around, the answer will come out, for the most part, the same. That's only in a straight addition property, as you'll see a little bit later. Let's try multiplication. Remember, multiplication is grouped addition. Instead of adding, no, you just multiply. 4 plus 4 plus 4 plus 4 plus 4 is 20. Or how about 4 times 5 is 20. So you're adding, speed adding, or adding in groups for multiplication. So let's go 3 times 4 times 5. Okay? Equals. Now, if I put these in enclosures, I really don't need a dot or a times between there. Anytime you get a number times, next to an enclosure with no symbol in between them, that is multiplication. Unless there's something indicating another function, that's multiplication. 3 times 4, my friends, is what? 12. Let's say times 5 equals 60. We see how that works. That's pretty simple, isn't it? Let's change the enclosures. Move the enclosures around. Let's see what happens next. Again, let's see what happens. We do what's in here first, right? 4 times 5 is 20. Times 3 equals, well, what do you know? Cookies and cream. We're back at 60 again. So as we see, the associative property works for multiplication as well. Okay? Not bad. Let's see what happens when we try to subtract. Straight subtraction. And it doesn't matter what order, well actually it does matter when you put this. Now, we have a symbol between these two. So, that's a subtraction problem. So watch this. 3 minus 4 is -1 minus 5. -1 minus 5 equals -6. That seems fair enough because that's the true answer. Let's move these enclosures around and see what happens. I'll get rid of you here. I'm going to do this. Let's see what happens. Now, 4 minus 5 is what? -1? The funny thing is going to happen right now. Another rule in math, when you subtract a negative number, you're actually adding a positive number. So the symbol actually goes from 3 minus -1 to 3 plus 1. Isn't that a different answer from what we just had? So as we see, it does not work for subtraction. You can't move the brackets around. It's not going to work. Well, guess what? If it doesn't work for subtraction, it's not going to work for division. And let's see why. If you go 3 divided by 4 divided by 5, you can already see this is going to be an issue. So remember what I said, the rule of that divisor sign, you go here, you go here. So you can write this like this. Now, another rule in mathematics, I'm going to make this fast. You really don't know how to divide fractions. So what we'll do is this. Now, you can't really divide fractions. They really don't know how, but you can multiply what we call a reciprocal. You flip the number over. And remember what I also said is whenever you see a number solo, it's like this. And you multiply across. That's what happens when you do it that way. Let's move the brackets. By the way, that's 3 3/4. If you really want to break this down, you can have an answer like this. It's not wrong. Early in math, they'll teach you to break down what they call an improper fraction, where the numerator is bigger than the denominator. The number on top is bigger than that on the bottom. They kind of don't want to see that early on in math, so they'll have you do this. They'll have you break it down. So 4 goes into 15 3 times with 3 left over. Okay, so this is what happens when you do it this way. Let's move the enclosures and see what happens. So let's see what happens. 3 divided by 4, let's do it this way. Or much different answer, isn't it? Much different answer. Remember, we don't really know how to divide a fraction. So what we do is we flip this over, what we call a reciprocal, and we multiply. The 5 stands alone, it's like 5 over 1. 4 times 5 is 20. 3 times 1 is 3. You don't want this early on in math, so this is your final answer. Okay? Doesn't work for division if you move those brackets around. Now we just saw how. That, my friends, is the associative property. So what we learned, the associative property works for multiplication and addition. It does not work for division and subtraction. Let's go to the next. Okay, the next property we're talking about now is commutative. Commutative, to commute. Kids, if your parents live a distance from where they work and they have to travel to work a great distance, is called commuting or moving. So what that truly means, when we had the associative property, we moved the enclosures. This time with commutative property, we move the numbers. So 3 plus 4, I would say equals 4 plus 3, right? Well, 3 plus 4, as we know, is 7. 4 plus 3 equals 7. All day, all night long. Okay, chances are if it works for addition, will it work for multiplication? Let's find out. 3 times 4 is 12. 4 times 3 is 12. Seems to work pretty good for me for multiplication and division. Excuse me, for addition and multiplication. Do you think it's going to work for subtraction? Let's find out, my friends. Let's just change the symbols here. Watch this. I guarantee you this is not going to work. 3 minus 4 is what? Negative 1. 4 minus 3 is 1. Ooh, that don't seem to work, do it? No. 3 divided by 4. 4 divided by 3. 3 divided by 4 is going to look like this, 3/4. 4 divided by 3 is what? 4/3 equals 1 1/3. Actually, I'm going to leave this here. This does not equal. Anytime you see this here, an equal sign with a slash, it doesn't. As you can see, 3 minus 4 equals negative 1. 4 minus 3 equals 1. Negative 1 does not equal 1. Not or nothing. No, no, no. As you can see, 3 divided by 4 is 3/4, or 0.75. 4 divided by 3 is 4/3, or 1 1/3. As you see, it does not work. So the commutative property only works for multiplication and addition, but it does not work for subtraction and division. Let's go on to the next one. Distributive property. Well, how this works is to distribute or to give. You know, if I have food and you and your friends are here and, you know, I have bags of lunch, I distribute them out to each of you. Well, that's the same principle in math. A, B, and C. So remember, there's nothing between here, so it's A times B plus C. Well, how does distributive property come into play? Well, what we can do is we can expand this a little bit. So you expand this here, and you also do it here. So what that winds up doing is this. Right? That's basically the distributive property in a nutshell. Okay? You distributed A to each one of these. Right? So if we give these number values, it would work. Let's say if A equals 2, B equals, so it would be like, so then we go here, 2 times 3 is 6, 2 times 4 is 8, see how that works? The 8 looks a little funky, but you get the point. Okay? You distribute this in here. Well, what happens if we add this together? Right? Let's do this. Let's add these two together. So let's go A times, if this is 2, and B is what? 3, and C is 4, right? We do what's in here first. 3 plus 4 is 7. And 2 times 7 equals 14. Numbers don't lie. As you see, distributing that and then doing it this way, all I did was move the A to here and move the A to here. In other words, we made the A common to both. Now there's going to come a time when you get into factoring later on down the line, you'll see this and you'll pull this out of here and your number will look like this. But for right now, That's the distributive property in a nutshell, where the number outside of the enclosure is next to it. You distribute it inside to each of the inner components. Now there's another way of doing, you can use the distributive property in another way, and it'll be like this. You not only do that with numbers, we can also do that with symbols, right? So if you see this out here, right, everything in here changes. This symbol changes, so it's going to be like this. Or really like this, because everything in there changes. That's the distributive property. The inverse property. This is important. The inverse property is important because of this. On this side, this is actually called the additive inverse. And I use A. You can use any number you want to. 1, 11, 50, 89, it doesn't matter. But if you have a positive number and you subtract that same value, you're going to get 0. That's called the additive inverse. Okay? Conversely, if you have a negative number and you add its positive value to it, it's going to also equal 0. Now, what this does is, remember when we did a math problem earlier, we did something like this, 12 minus A, well, we do it like this, 12 plus A equals 17, and we subtracted 12, and we subtracted 12. This is the additive inverse right there. That is the additive inverse. What we did was we took a positive value, we subtracted or added its negative value to it, and came up with 0. That is the additive inverse. If you did it the other way, it does not matter. The point is, you've heard the term zero out. Well, that's what you did. In addition, it's called the additive inverse. Multiplication, very similar. The multiplicative. I know that's a difficult word for you children. Multiplicative. The multiplicative inverse is this, where you take a value, and this is what we call a reciprocal of that value, where you put a 1 over the top of it, it's going to turn out to be 1. If A, say, equals, let's say, 6 times 1 over 6, right? Well, remember, if you want to write it out, this 6 can equal this. 6 over 1 times 1 over 6. The 6's cancel out, the 1's cancel out, it equals 1. And in division and in multiplication, that is also important. And I'm going to show you why real quick. Remember when we said this, 3 times A equals 12, right? We did this, didn't we? Right? Remember this? That's the same as doing this, 3A times 1 over 3. If you want to do it that way. These two cancel, right? You're left with A. See that? That is called the multiplicative inverse. And it works that way as well. Inverses are rather easy. You're either going to zero a number out when it comes to addition, or you're going to single that out and let that variable get by itself when it comes to multiplication. Okay? So inverse is rather easy. Let's go on to the next one. The last of the properties we'll cover real quick is the additive property and the multiplicative. There's that word again, multiplicative. The additive property is simple. Any number that you have here, A could be 50, but you have a 0 here, 50 plus 0 will always equal 50. 0 is the additive identity. In other words, whatever this number is, if you add 0 to it, it's going to be that same number. The same goes for multiplication, multiplicative. But 1 is the factor number. If D is, say, 11, 11 times 1 is 11. And that number is the identity of it. So any number times the number 1 is that number. That's multiplicative identity. Okay? Additive identity, any number plus 0 is that same number. Multiplicative, any number times 1 is that number. Okay, those are the 5 properties of math. As we get along and go along and move along, we're going to see exactly how this comes into play. For every math problem we'll do, I will call out every property that we use. Okay, I hope you enjoyed this. Had a little bumbles and fumbles. Maybe I'll put that on my blooper reel as time goes on. But I hope you understand what I went through. Any questions, any comments, please leave them. Remember to love one another. Be good to one another. Be kind to one another. Because it's really in this world all we have, okay? God bless you, and hope to see you in the next video.